Hi, my name is Stephen McGee and I am the author of Toxic Electricity. I'm here today to look into grounding systems, and that's this connection right here. And this cable goes all the way down here and connects onto the grounding system of the house through the power strip. Right here we have a non-electrified grounding connection, which is in my back garden, far away from any electrical systems. That's our reference, and this is what we get. So pretty much at 4 volts AC peak to peak, we're actually on 500 millivolts per division in the vertical direction, and we're on 5 milliseconds per division in the horizontal direction. So what we're looking at is 60 Hertz AC on the utility system grounding connection. And the thing I want to get over to you is that grounding systems are very, very rarely ever at 0 volts, as much as the utility company would like you to believe that they are. They aren't. The voltage increases according to the load. And I've had to wait almost a year to do this video because I've been waiting for everybody to put on the air conditioning systems, because once everybody puts on the air conditioning systems, the load gets very, very high on the electrical system, as does the voltage on the grounding system. And for those who don't really understand what a grounding system is, it's actually the neutral connection of the utility transformer in the USA. So this connection goes to every transformer neutral connection on the system, and that's why we have a voltage on it. So the ground is not actually at ground potential, it's actually at 4 volts AC peak to peak. So the interesting thing about this particular voltage is it's actually reported in the dairy industry as stray voltage. It's actually very well understood back in the 1970s in the dairy industry. And they know that this voltage that we're looking at right here is enough to kill a cow. Anything around 2 volts or above AC, long-term exposure will actually kill a cow. So it's something to be very, very concerned about. And what I'm going to show you is the frequency content of this waveform. And I'm going to switch on a function called the fast Fourier transform function. So this is our frequency content. What we're actually looking at in the vertical direction, every square is 20 decibels. And in the horizontal direction, every square is 250 Hertz per division. And right here, this big spike over on the left is the mains frequency, that's 60 Hertz. And these other big spikes tailing off are known as the harmonics. And harmonic is a repeating 60 Hertz frequency. And in particular, what we can see is the odd harmonics, which is quite typical of a utility system. And all that flickering you can see down on the base is just electrical noise on the system. As you can see, it's a very noisy electrical system that we're actually measuring right now. But what I'm going to do, I'm going to extend out the frequency because there's far more frequencies in there. So right now we're on 250 Hertz per division. Let's see what happens when we go to a kilohertz. So now on a kilohertz, and we can see that the harmonics are condensed into here now. We've got a lot of noise, but it's starting to spike up again. So let's see what that spike is. So I'm going to switch it on to 10 kilohertz per division. So there's 10 kilohertz per division. And what we can see is we come into another set of harmonics, and that's the 10 kilohertz harmonics. And we can see that they're repeating every 10 kilohertz. So here's the first one, and these are the repeating harmonics of that. So let's go on to the next range, which is going to be 100 kilohertz per division. So we're now at 100 kilohertz per division. We've seen a whole new bunch of frequencies come in. And pretty much anything from here onwards is the AM radio band. And we can see that there's a whole bunch of frequencies in there that you'd be able to pick up on a standard AM radio. And if we were to put a standard AM radio next to this ground cable, we would probably detect them with the AM radio. So there's something to be aware of. You know, if you use anti-static devices, you're connecting into these frequencies, and it's very well known in the dairy industry that any voltage source that, like this particular one at 2 volts, will make animals very sick. In fact, they say anything over half a volt will make animals very, very sick. And then you throw in all these frequencies that are in there that are nothing to do with the 60 Hertz, that have other sources of where they're coming from, then you're going to get quite sick from all these various frequencies that your body's getting subjected to. So let's go up to a megahertz. So now on a megahertz, and we can see that we've still got all this flickering, which is just, a lot of it is electrical noise. The oscilloscope base noise is actually much lower than that. So we've got a very noisy electrical system ground, and we've got these very large spikes that are centered between 0 and 2 megahertz. And contact with that will make you quite sick. And something to be wary of is that if you do use these anti-static devices, that they may well have these frequencies on that may make you get quite sick. So if you use anti-static devices, you're feeling quite sick, I would suggest that you stop using them and see how your health is, and you'll probably find a significant improvement in your health. So there you are. We appear to have gone right through the range of frequencies that are present on the grounding system. They actually go much higher, but they appear to be of a much lower level, the higher range of frequencies, above 2 megahertz. And I hope that you found this video informative, and if you want to find out more about this subject, you'll find it in the book called Toxic Electricity. I wish you the very best of health, and I hope you enjoyed this video. Thank you.